In this example, we'll learn how to solve the integral of the function 1 over x times x squared minus 1 using substitution. Let's start by writing down the integral we need to evaluate. This is the integral of 1 over x times x squared minus 1 dx. To approach this integral, we will apply substitution. For a substitution, let's look at the denominator of our function and select a term we can differentiate easily. Here, we'll substitute u as equal to x squared minus 1. Let's do this substitution first and figure out how the differential dx changes. When we substitute, we need to compute the differential, or in other words, how dx changes with respect to do. So let's differentiate u. The differential do will be equal to 2x times dx. Let's solve for dx in terms of do. We'll divide both sides by 2x to isolate dx, so dx becomes 1 over 2x times do. Next, substitute back into the integral. The integral becomes 1 over xu times 1 over 2x times do. You'll find that further simplification will result in a problem. The integral still contains x, which needs to be expressed in terms of u. Use the substitution for u. From u equals x squared minus 1. Solve for x as plus or minus u plus 1 under the square root. Replace x in the integral. Now, the integral becomes 1 over 2 times the integral of 1 over u to the power of 3 halves. Once substitute differentiated again to solve in its terms. Substitution is usually quite nice. After simplifying, you can always reverse back to its original variable. Here's a simplified procedure. With everything taken into account, the integral becomes negative 1/2 times the integral of 1 over u plus 1 caret 3, which integrates to, and finally, we just need to resubstitute x back into u to get our final result. The integral of 1 over x times x squared minus 1. Dx simplifies down to negative 1/2 times the natural log of the absolute value of x squared minus 1 over 1 plus x squared, plus the constant of integration, c.